In the last video, we learned about text segment and code segment portion of the program memory, which were basically the memory allocations for the functions as such, the logic of the function. Now, where we left last time was what happens to the variables that are there in the function. Do they get allocated in the same space as the text/code segment, or do we have another set of memory for that? So let's go through this function again and see what happens to how the memory is allocated for these variables. So we can clear these variables. Now let's see what happens for a. So f4 ampersand a will give us address of a. f4 ampersand b will give us address of b, and ampersand sum will give us address of sum. So what happens here? So the thing is, we had certain memory allocations for the functions as such. Now the starting address that we have for a is 22FF44, which is very different from 401290. So in fact it is a much lower memory address compared to where our program started. So the first variable that gets allocated is a, and it has a memory address of 22FF44. Now next variable is b, and interestingly it gets a lower memory address, whereas in case of functions, for the main function we got the lower memory address, and function add we got the higher memory address, because main is the first function that we start. Now if we go by the sequence, a is the first variable that gets allocated and b is the next, but the address that is allocated for b is actually lower than a. Now why does that happen? So that happens because the compiler stores these variables in a different portion of the memory, and that's what we will be focusing on. And that memory location, as it seems from here, grows in a reverse direction, as in the first variable that gets allocated gets the highest memory, and the successively later variables get lower memory addresses. Now also another thing we see here is the difference between the memory addresses for these variables. So if you see between a and b there is 4 bytes of difference, b and sum there is again 4 bytes of difference. Now where is this difference coming from? So recall that the size of an integer is 4 bytes on typical machines. Typical machines means if the machine is 32-bit and the compiler is 32-bit, then it's mostly the case that the size of these integers will be 32 bits or 4 bytes. So let's say in this case, as we can see here, there's 4 bytes of difference, and if we look at the size of these integers, it will actually be 4 bytes. So hence the starting address is 44, and 44 to 41 is the memory that gets allocated for integer, which is 4 bytes, and then 40 to 3d gets allocated for b, and 3c to 39 would get allocated for sum. So 4 bytes each. Now let's proceed and see what happens to these variables next. So although sum has, we are passing this variable sum also in the argument, although it is not required, but it's just to kind of see how the memory gets allocated for these variables. So we can see here that it is 44403c in a decreasing order by 4 bytes. Now let's go step into this function main. To step into the function, we can do shift F7, or from here debug menu we can go inside too. Now we see here that we have entered into the function add, and these memory locations are still showing the same addresses. So let's refresh these variables and see what happens. ampersand A. So it gets updated if you see. So from FF44 it gets updated to 10. In fact, it is just that here these variables have not been refreshed, so it's holding the previous value that it had in main. But now let's see what happens to these variables in function add. And that was primarily the reason that I passed these all the three arguments, although we did not need sum in this function call. So let's see what happens to B, address of B, ampersand B, and ampersand C, ampersand sum. So it is interesting now to see here that the address of sum is actually the highest out of these four variables that we are looking at in sum in function add. And if you recall, the address of A, it was ending in 44, and the address of sum was ending in 3C. So both those addresses are higher compared to all the four addresses here, and the integer variable C, sum, gets the highest address, and then the next 4 bytes is for B, the next 4 bytes is for A, and then after that there are about 8 bytes that get left. So 4 bytes for A from 10 to 0C, and then 0C to 08 is also left. So it's basically 8 bytes that are left after A. So this is more of a compiler thing, how it handles the parameters that are passed into the for the function, and then integer C, it considers that it is defined after these parameters have been assigned, memory addresses and values. Now let's see what happens. So what we observed here is we have a memory bank, let's say something like this. Okay. Now the highest address that gets allocated is for the first variable in function main, which is A. So this is ampersand of A. Okay. So this gets allocated A. Then next is variable B, which is ampersand of B. Next is sum, which is ampersand of sum. These are the addresses, right? And then what we see interestingly is it leaves a few bytes of memory, and the same although the variable names are the same, A, B and sum, that are passed to this function add, it gets allocated a different memory location. So inside this we get allocated A, B, sum and C. Okay, and the difference between this and this is actually 8 bytes, and all these others is actually just 4 bytes. So similar 4 bytes for each of these. Okay, so these are 4 bytes wide for integers, as we have seen here, and the memory address goes in a descending order for all these allocations. Actually, this thing I should take it back. This is not A, this is sum. This is B and this is A. Okay, so that's how these get allocated, and C gets allocated like this. So which means that it is starting from some higher memory address. So this is some 22FF10, 22FF10, actually not that one. So this one gets allocated here, the memory address of, not this, let me strike that off. So this one gets the memory address of 22FF18, then this one is 14, and this one here is 10, and this one here gets the address of 04. So we see that it is in a decreasing order, and this is the part that we have